This is a direct follow-up from the last video, and we're just going to look at some more synthesis examples together. All right, so here's our example. We want to go from this ketone to this amide. So when I first saw this, I was a little confused, trying to think in this chapter how we would go from a ketone to a carboxylic acid derivative. And it wasn't until I started thinking about reactions that we learned last chapter that a good path came to me. If we start with a ketone and we use the Baeyer-Villiger oxidation, we can insert an oxygen atom in here to give us an ester. And then once I'm into a carboxylic acid derivative, then I know how to get around to the other carboxylic acid derivatives. So with the Baeyer-Villiger oxidation, we want to react our ketone with a peroxy acid. And so the book might use RCO3H as a reagent, or we could use MCPBA. So what that Baeyer-Villiger oxidation does is it inserts an oxygen atom on whichever alkyl group is more substituted. So here I have a secondary carbon, right? It's got two alkyl groups coming off. This just has one, and so we're preferentially going to put the oxygen here. And it inserts it. So whatever this alkyl group just gets attached on to the end of the oxygen. Okay, so now my goal is to get from this ester into this amide. Now, we did see that we can directly go using aminolysis between an ester and an amide, but we did mention that that reaction is pretty slow and inefficient. So a better way would be to get this to the acid halide, and then we convert that into the amide using aminolysis. So to get this to the acid chloride, I'm going to first take it to the carboxylic acid and then to the acid halide. So since we want to do the opposite of Fischer esterification, we're going to go with acid catalyzed hydrolysis. To give us a carboxylic acid, then SOCl2 will get me to the acid chloride, and finally 2 equivalents of the amine and I want 2 methyl groups on that amine so that I get my 2 methyl groups here. And that'll give me the final product. Okay, in this case, we're starting with benzene, and then we want to end up with the benzene ring with a carboxylic acid derivative. Specifically, we want an acid anhydride. So the first thing I want to think about is how do I functionalize this benzene ring? And so this makes me think of the nucleophilic aromatic substitution reactions that we learned a couple chapters ago. And in the chapter before that, when we were looking at reactions of benzene, we saw that if we had an alkyl group coming off a benzene ring, the benzylic carbon was really reactive. And so what I think I might want to do is use the Friedel-Crafts alkylation to put an alkyl group on here. Then I can oxidize it with sodium dichromate, which will chop off all of the alkyl group and just leave me with a carboxylic acid. And then once I have a carboxylic acid coming off my benzene ring, then I can go to the reactions from this chapter to convert that into the acid anhydride. So first thing I do is just stick a alkyl group on. There's no point in wasting a bunch of carbon atoms, so I'll just put an ethyl group on. All right, now I want to oxidize this. With sodium dichromate. sulfuric acid and water. So what that does is it's going to chop off whatever the alkyl group is and just leave me a carboxylic acid coming off of that benzene ring. All right, and then we need to get from our carboxylic acid to the acid anhydride. And if we think back to the preparation of acid anhydrides, the best thing to do was to get my carboxylic acid into an acid chloride. And then I want to use a carboxylate group as a nucleophile in one of these nucleophilic acyl substitution reactions. And so the carboxylate group that I want to add is this. And so I'll include the sodium as the counter ion. So I'll be using this salt as my reagent. This carboxyl group will act as the nucleophile, replacing the chloride and giving me the desired acid anhydride. Okay, in this final example, I want to convert this starting material into my final product. So a couple things jumps out at me. So, okay, I've got a carboxylic acid derivative. I'm making an ester, so that fits in the reactions we've learned in this chapter. But when I think about this starting material, what I also notice is I'm adding two alkyl groups, two identical alkyl groups. And so the reaction of forming new carbon-carbon bonds that add identical alkyl groups, this makes me think of the Grignard reactions. So if I can convert this into either an acid halide or an acid anhydride or an ester, I can react that with a Grignard reagent where the methyl group is the R group, and that'll attach two methyl groups here, and I can worry about getting that to, then converting that into the carboxylic acid derivative. So my goal, turn this into an acid chloride. So I can go from a nitrile to a carboxylic acid by hydrolyzing it. Then hit it SOCl2. To get the acid chloride. Now I'm ready to react it with my Grignard reagent to add those two methyl groups. So the Grignard reagent I need to use has two methyls for the R groups. Then I need the water workup. I add the two methyl groups. I also reduce my carbonyl group to an alcohol. And so now I have an alcohol, and I want to convert it into an ester. So one of the ways that we've seen to make esters, if I start with an acid halide and then react that with an alcohol in pyridine, that will give me an ester. When we first saw this reaction, we generally had the acid chloride as the reagent, and then we were adding the alcohol and pyridine, but there's no reason why I can't start with the alcohol as my starting material, then add to that the acid chloride to attach this to the alcohol, and then use pyridine to neutralize the hydrochloric acid that's going to be produced, and that will give me the final ester.